Our speaker is a longtime traveler in the world of IT, dot connector, cartographer of uncharted territory, keeper of timeless wisdom, translator between floors, system design, resilience, sustainability. He dislikes long bios. Which is great, I love that. He tries to make IT a better place. Let's give a big CraftHub welcome on to Uwe Friedrichsen.
Thanks.
Just a quick question for you.
Yeah.
We all know this is CraftHub's 10-year anniversary.
Yeah.
And this whole industry has transformed in 10 years, and it's probably accelerating even faster now. Mm-hmm. My question to you is, through all your wisdom and knowledge that you've gained through the years, what kind of advice would you give to programmers or system engineers that are just starting their career?
Be curious, simply. And also, leave your comfy chair once in a while and see what's going on there outside, so beyond the keyboard. And because that gives you a lot of insights which you can then use to fuel your career when you're on the keyboard.
Uwe Friedrichsen.
All right. So, hello, and yeah, as we know, this is a lunch coma slot. So, if you want to fall asleep a little bit, okay, I'm trying to not to scream or something like that so that it will be quite relaxing for you. For the other ones who stay awake, I will talk a bit about resilience. And first of all, I will try to clarify what resilience actually is. I talk a lot to people about resilience, and most people, they have very different understandings. And some of them have something to do with resilience, some of them have not. And so try to clarify that. Afterwards, I will try to show a typical journey that companies go through on their way towards resilience. And at the end, I will briefly touch the question, do we always have to go the full way, or is it okay to stop somewhere in between? My name is Uwe Friedrichsen. I work at a German-based company called Codecentric. We're doing software engineering consulting, so yeah, nothing surprising. And on the internet, you usually find me with my handle UFried, so on Twitter or X, how it's called these days, and Mastodon and Blue Sky, and also with LinkedIn and blah, blah, blah. You can find the unabridged slide deck at Speaker Deck. So because I have to cut things a little bit shorter here, because we only have about roughly 35, 40 minutes, and it's a bit more of content. And I also run a blog where I'm just in the process of writing it all down so that if you want to read it up later in the year, you can go there and try to read stuff there. But let's get started. I talk to lots of people, as I said, managers, also developers, engineers, architects, blah, 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 and talking a lot about resilience. And so I hear often, yeah, we are resilient, and or, yeah, we're quite resilient, but you need a little bit more. And the first question I always have is, well, are we talking about the same thing? And the reason is, resilience is usually, it is something different than most people think it is. I went through a lot of definitions of resilience, so from lots of domains, so from psychology, from systems engineering, from supply chain management, organizational engineering, and from lots of other domains, and tried to find a common bottom line. What is it, this resilience thing? And what I figured out is resilience is basically the ability to cope with some kind of adverse events and situations. And it includes several things. So first of all, you must be able to handle expected adverse events and situations. So things that come to our mind. But that's not really resilience. That's robustness. That's a part of it. I mean, we need to have that to become resilient. So, for instance, if you talk to people in safety critical environments, they don't even mention that anymore because, well, things have to be robust. So, but the next thing is, which makes it interesting, we must be able to handle surprises, things we did not expect to happen. And that's what most people forget usually. And the last thing is, it's not everywhere in all definitions, but in some, it's that we're able to be better off after the event than we were before. That's anti-fragility. It's also included in resilience, basically. And if you say, well, but we read the book, Anti-Fragility from Taleb, and he said, well, resilience and anti-fragility is something very different. Yeah, he used a very tweaked definition of resilience, where he said, okay, that's all not part of resilience, and therefore anti-fragility is something different. But if you go through all the domains, they say, well, it belongs to it. So that's resilience. And by the way, lots of people also talking about resilient software design, including me, and basically that is, how can we create dependable systems in some way and support resilience up there? As we will see on our journey, systems alone have a hard time to be really resilient, especially with regarding surprises. And just to give you a little bit better idea, beyond this dry definition, what resilience is basically means is here's some examples of failures that could happen to you. Like, okay, everybody thinks about hardware failures. Yeah, machine crashes. Yeah, sure. But latency, oh, there are already quite a lot of companies I've seen who never thought about that, or something that is something wrong in their firmware and their infrastructure. So I had that once, so that our top-of-rack switches had a firmware bug, and they filtered out some kind of packages, and, well, all of them, because we have had all the same core switches, and, well, we had a hard time with that. Cyber attacks, yeah, some people think about that too, because quite some people say resilience is only about security, which is not. Software bugs, very often omitted. So, yeah, well, it's... And then some surprises. I had that once while I was running production of a data center, and, well, yeah, we had a triple redundant cooling unit, and, well, all 3 units failed at once. Nobody ever planned for that. Or also in the business domain. And some people saying, well, the business domain is that's something different. It's something changed in the business domain. It's something that happens there. But this digital transformation thing, which many people talk about, and the people who knew least about it talk the most about it usually, basically means that it's nothing new. I mean, we're doing it for 70 years more. Meanwhile, we started to digitize some business functions, later business processes, then the interaction with the users. And meanwhile, we are digitizing whole business models. So think about Stripe.com, a whole revenue stream simply going through an API. And we're creating new business models, and all these things mean in the end, so it means few things, digital transformation. But one of the effects is business IT are the same thing these days. You can't separate them. So business IT is business. And it also means whenever something happens to business, we have to touch IT if we want to change it on the business side. So you can't move faster on the business side than you move in IT. Side note, if you run your IT still as a cost center, you also run business as a cost center, like it or not. But it's digital transformation these days. And so it all affects us. And this is all about resilience, actually. Okay, so quite often then we figure out in our discussions, well, we were talking about different things, but it looks quite interesting. So how do we get there? And the first thing I especially tell decision makers then is, well, it's not a 3-bullet point list that you simply can check off or something like that. It's a little bit more of work getting there. So it's more like a mountain climb. So it can be exhausting and a bit tedious, and there are obstacles in the way and all these things. The good thing is we're not trying to climb Mount Everest. We're trying to climb Mount Resilience, and it's climbable without professional equipment and oxygen mask and stuff like that. Still, it's a hard journey getting there. So, and what I tried now is to lay out a prototypical journey. So your specific journey may be a bit different, like this one. But we start out there in a nice valley or lake, it's green out there, then we go up and there are some plateaus in the way and there are some obstacles in the way until we may eventually hit the peak of Mount Resilience. And okay, let's start down there. I call that the Valley of Feature Completeness. It's where many companies still are. The Valley of Feature Completeness is basically the status quo for many organizations. So it's this idea, so dev is responsible for features, and ops is responsible for availability. Basically, if we talk about resilience, I mean, one of the core metrics is availability. How often does our system, or what percentage of time does our system respond according to the specification? There's another metric, reliability, which becomes more interesting in safety-critical environments, but we leave it out for the moment because not every one of us is working in safety-critical environments. So we focus on availability in this presentation. And so we have this separation of concerns, sort of, so that everyone except operations is only focused on business features, and availability is basically outsourced with all the other production relevant quality attributes to ops. So they have to make sure that it's working this way. So if we try to create a more formal specification, we say, okay, the core driver for most of the business is then we try to maximize feature throughput. So especially the dev department doesn't care about availability. So that's somebody else's problem, isn't it? And so the leading questions left over here is, did we do things correctly? How can we increase efficiency? So getting more done with less money, and so on and so on. And the typical questions, if we go back to resilience, or more precisely to availability, is then everything that ops can influence. And so they do what they can do, basically. They set up some kind of redundant hardware. They use load balancers with failovers or some cluster solutions and so on. They have some strict handover rules for everything they get from ops, from dev, because they don't trust dev, because they are not caring about production dependability, and long testing phases, blah, 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 all these things. And we see it quite often, but is there a blind spot? Well, I wouldn't call it a blind spot. I would call it a blind everything with little seeing spot. The problem is that only ops is looking at that seeing spot. So basically, they ignore everything about besides business features, and especially they ignore the reality of today's system landscapes, so that this is not working very well anymore. Which brings us to our first insight that we need to start our journey. I mean, why are still so many companies working this way? Because it worked in the past. But in the past, our system landscapes look differently. In the past, our system landscapes basically consisted of quite monolithic, isolated systems, which exchanged information via offline batch interfaces. So we had that till the 2005 or something like that. It was sort of a tipping point, basically. But up to then, most of the time, daily updates, so a transfer file or transfer data table was written, and then some other system eventually picked that up once per night or once per hour later, and so on. But it was offline. So there wasn't a lot of problems with communication between systems. It's well understood so how this kind of batch updates work. So the biggest problems they had in these times were either there was a software bug, okay, that was devs and QA's responsibility to eradicate that, or that some part of the underlying infrastructure or middleware or hardware was failing. So, and that was ops responsibility. So ops was responsible for that part. And if we get these parts, two parts right, well, we're basically done. Unfortunately, system landscapes changed. We went from offline batch to online communication, request-based like REST or event-based or. But now, these days, we're working with highly interconnected, continuously communicating system landscapes. We have a huge distributed systems in place, basically, even without microservices. Microservices just reinforce things. But basically, it's highly distributed. Online communication, on-demand communication, single record communication, all these things. And this means that all the failure modes from distributed systems become relevant. And so we can't just say, okay, it's only problem that we have is that our underlying infrastructure is failing, but everything from every side can fail, and we can have latency and all these things. And this will also hit us at the application level. So we can't simply say, okay, ops take care of that, because it's application to application communication. So how should ops take care of that? They don't have a handle for that. And so we need to realize, okay, it's not an ops problem anymore alone. So we have to include the rest of the IT department too. Which brings us to our first plateau. I call it the plateau of stability. It's this first step that companies are usually doing, trying to change as little as possible. It's an interim step. And this first step is basically that companies extend this notion of ops has to avoid failures to IT has to avoid failures. So also the dev department implements and sets up applications with this let's avoid failures mindset. So the question is then, how can I avoid the failure of my application, and how can I detect that and do some kind of failover? And interestingly, most of the time, these companies only thinking about two kinds of failures: crash failures, so from the past, basically, and overload situations. That's what I see quite often there. So either how can I avoid crash failures or overload situations, or detect that and do some countermeasures that they don't become effective. So the typical measures what we see here is then still redundant service deployment, but now dev configures it, and we see some kind of patterns like timeout error, error checking, retry, circuit breakers, and so on. Maybe some kind of rate limiting in place to avoid overload situations, or maybe if you're in a cloud environment, you use auto-scaling. And the interesting thing is that this kind of division of labor changed a little bit, so it's not ops who's doing all the stuff, but ops says, well, I don't know what's the right parameters for you on the application side, so we give you the tooling, so redundant service deployment, Kubernetes, deployment descriptor, the other stuff, timeout and so on, it's a service mesh and rate limiting, it's the API gateway and auto-scaling, it's the cloud environment, and so on and so on and so on, and the dev folks then do their configuration parts for that. And one last note about that one, it's a focus on the technical measures only, so nobody's talking to the business department. It's still contained inside IT. Little change, it's quite easy to set up. It's not so much of a change from where we're coming from. And in terms of availability, it's quite good availability is achievable. I would say the rule of thumb, less of 3 nines, so 99.9%, less of that. If you still have planned downtimes and so on, that can be okay. But what's a blind point, or this blind spot in here? It's what I call the 100% available trap. All these things are set up with a mindset that I can completely eradicate failure, that I can avoid failure 100%. So, for instance, we see it, so this mindset, so operating system will never fail, schedulers or something like the routers or switches, they will run 100% of the time. I don't have to care about that. And the middleware components, they are running all the time. As soon as we've sent the message to the message queue, we're safe. So message queues never fail. Or also all the other services out there. So this mindset is some kind of induction proof. So everything's running 100% of the time. And only if I add something to that, I also only have to make sure that my stuff is also running 100% of the time. And hey, we're safe. So, okay, people will say, failures could happen, but think about that. So it's basically continuation of that ops is available, a responsible availability mindset. So everything I do not program is not my concern, basically. I make sure that this stuff is going, and then everything will be fine. Now, I've seen whole system landscapes crashing down because of that mindset. As Michael Neigert put it, continuous partial failure is a normal state of affairs. Or, as Werner Vogels describes distributed systems, everything fails all the time. Well, that's reality. And so we need a little bit of a shift of a mindset, which brings us up to the next plateau. And this is this idea that we cannot avoid failures. Failures will happen, so we cannot make sure that nothing ever happens. So we have to go back to our formula for availability. I mean, in the end, we're not interested in avoiding failure by all means. We're interested in maximizing availability. And if we go to the right-hand side of the formula, we see two terms in there. Mean time to failure and mean time to recovery. Mean time to failure is system starts running, works, and then something bad happens, so failure happens. It doesn't work according to its specification anymore. Mean time to recovery is, oh, something bad happened, until we're back to normal, so works as expected again. So in the denominator, we have the whole time, and up there in the numerator, we have the fraction of the time where the system worked as intended. This stability mindset basically thinks we can increase mean time to failure to infinity, because if you make that really, really big compared to mean time to recovery, it means that availability gets closer to 1. So, and if it's really, really big, then we have a high availability. The problem is failures will happen. So there is a limit to what we can achieve with mean time to failure. And this means if we want to increase availability, we have to look at mean time to recovery. How fast can we get back to business if something goes wrong? So we have to look at both things. The mindset, the stability mindset is, wow, yeah, let's get mean time to failure to 1 million hours. That's more than 100 years, and so we don't have to care about mean time to recovery. We don't care if it's 5 days. But if mean time to failure is 1 month, which is a good time, then 5 days makes a difference. Or if it's 5 minutes. And this is the second insight that you need to move on your journey. And while you're thinking about what can go wrong, you also realize then, well, it's not only crash failures and overload situations. There are a lot of failure modes out there. The other ones of distributed systems and software bugs, firmware bugs, security vulnerability, blah, 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 blah. A lot of stuff that we have to think about and think about how we can respond to that in a good way, how we can recover quickly, how we can avoid that in some way, and. And so we move up to the plateau of robustness. The core idea of plateau of robustness is then to maximize availability. So we go away from avoid failure to embrace failure, basically, in our mindset. It's a quite big shift in mindset, actually. It is a bigger step than going from nothing to stability. And the questions then that we have is something like, yeah, well, what can go wrong? How could we respond to that in a sensible way, in a quick way, actually? So if something else is not available, because before we said the other server is always available, but now we say, well, it's possible that it's not available. And how can we handle some kind of invalid request or some invalid information that we can't process properly? And bugs, how can I fix them quickly? And all these things. And therefore, the measures we see is something like fallback, some kind of change in the business logic, that we say, okay, if our plan A fails, what's a sensible way to respond in terms of business, of the domain logic, to still give the user a sensible response? Or complete parameter checking, so everybody says, well, we do that anyway. Yeah, well, if we were doing that anyway, 95% of all CVEs would be gone now. So, well, there's still room for improvement, something like that. Minimizing startup times, which gives us a lot more options. Of course, automation here for deployments, because software bugs. And we need a quite good monitoring to detect if something goes wrong. We do not need observability on this level, but we need a good monitoring at this level. The interesting thing is that we went up now to the business domain. Now we have to talk to the business owners. Oh, if this other system is not available, how should we respond? So we have to reach out our business domain. So it's not contained in IT anymore. Now we go out to the business domain. So the impact radius becomes bigger. It's a bit more of effort. We also touch processes a little bit with automation and all these ideas to become quicker in our response patterns and so on. Still, while we can achieve really good availability in here, there's still some blind spot left. I mean, for instance, Erlang, with Ericsson with Erlang, they were able, getting with these kinds of concepts, about 9/9 of availability. It was a very specific use case, telecommunication switches, but 9/9 of availabilities means less than 34 milliseconds downtime per year. These switches were running for over 20 years, so they had less than half a second downtime in these switches over 20 years. So that's quite a good thing. By the way, without redundancy. Okay, the power supplies were redundant, but no redundancy in the software. So it's an interesting approach, what we can achieve here. Still, there's a blind spot, which is the limit of our perception. And we thought a lot about everything that can go wrong, what we think that can go wrong. The problem is the things that do not come to our mind. And what we will realize over time is that surprises cannot be avoided. So there will be surprises, and especially if you're working in a safety-critical environment. Safety-critical means people will get hurt or die if your system fails. You have to take surprises into account. I mean, you cannot just say there after 10 people died and say, oops, I didn't see that one coming. I mean, it's a cool one-liner for a villain in an action movie, but it's not in such a situation. We do not want to be in this situation, so we have to deal with surprises. So just to visualize that a little bit in the terms of known knowns and unknown, we think about this upper left corner usually when we think about things that can go wrong. We have some implicit knowledge, the unknown knowns, but it's quite hard to make implicit knowledge explicit. So we might miss that. We might be aware that we will miss some things, but we don't know which they are. We have no clue what that is. That's this part of the iceberg that we do not see. And now we think about, how can we handle surprises in a proper way? So what about a user story? Hey, write some code to handle surprises. That's a bit challenging. I mean, maybe Jules has an idea later on in his talk how to do that. Yeah, he does. Perfect. So we all have to go to his talk later on. Double thumbs up, yeah. But at least I do not have any good idea how to phrase that user story. Maybe I'll learn something later. And so we figure out then, okay, we hit the limits of what we can do inside our technical system, in our software. And because our technical system, our software, they're really good for robustness, for all the things that we can expect. We know we can figure out ways how to handle them in there with technical means. If we try to handle surprises, at least partially, we have to go to this thing, it's a little bit overused terms these days, this social technical system. So the IT systems plus the organization around that, the organization that creates the systems, runs them, and changes them. Because very often we need humans in the loop to really respond in a sensible way to surprises. And therefore, we have to go further. You see, we're leaving the boundaries step by step, going more and more resilient. And this moves us up to this high plateau of basic resilience. The idea in the high plateau of basic resilience is, okay, expect the unexpected. So the ideas are not changing, basically, they're stacking up. So we're still trying to avoid failures to a certain degree. We are trying to embrace failures. So we try to maximize availability. But now we're also adding the next layer, which is expect the unexpected. And so the questions shift again a little bit. So how can I maximize the probability of detecting and responding quickly to something which I didn't anticipate? And which resources do we need in terms of capacity and maybe money and technical resources to be able to do these things? So, and how do I need to change the organization? You see, as a mere software engineer, you need allies now. You can't do that just inside your team usually. And the hardest thing is this, how can I balance resilience and efficiency? I mean, there's nothing wrong with efficiency. The problem is, beyond some kind of low-hanging fruits, if you try to increase efficiency, you have to reduce variance. So you see, this is my expected behavior and state of my system and my environment and everything. And so I try to reduce variance. So TQM, Six Sigma, all these things are all about reducing the variance. Because everything works inside this corridor, I can improve, make my production processes more efficient. The problem with surprises is that surprises do not care about your corridor. They say, hey, I'm out of here, I'm over there. And highly optimized systems, so in terms of efficiency, they respond very badly to a surprise, to something which is outside that corridor. For instance, let's go to, as an example, to supply chain. Supply chain is a highly optimized system. And let's take a surprise. Let's call that the Ever Given. It's a ship lying, blocking the Suez Canal for a few days. I mean, it's a small canal over there and just a ship lying there. And it's blocked, maybe a few hundred ships behind them. And then, well, the supply chain, the global supply chains took more than 6 months, some people say about 18 months, to go back to normal. And not only the traffic from China to Europe, also over in Southern America and everywhere else, because everything was like, hey, the ship's here, then, and here's the places where I can unload this cargo and blah, 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 blah. And everything was one surprise, one tiny surprise. And that's what we get if we focus on efficiency too much. And so resilience does not say, screw efficiency. Efficiency is good. But it says, well, you have to give up a little bit of efficiency to improve resilience. You have to expect the unexpected. You cannot minimize the variance to close to zero. Doesn't work. And this will be the hardest discussion, by the way, because all the companies right out there are efficiency obsessed. Efficiency is the high holy grail. Whatever problem you have, more efficiency is the answer. Which is bullshit, actually, in today's markets, but, well, it still is. They're used to it so much from the last 100 years of production paradigms, industrial production paradigms, and all these things, that they are still only thinking efficiency. Well, anyway, if we try to improve resilience at this level, we come to measures like self-organized teams, like some kind of chaos engineering, fire drills, trying to figure out if system responds. We have to put Slack into the system, also into the organization, not the tool, real Slack. So sometimes some capacity to respond to these adverse events. We need observability. We really have to be able to ask questions. How's the state of our system? How does it behave? How it's going to be? And maybe some ideas of organic computing will help, or whatever Jules later talking about, and so on. So there's quite some stuff going on. And interesting thing is now we extended our focus again. So we are now going from technology to business domains to process to organization. The further we go to the right, the harder it's to change. So we need allies to get there. We still have a little blind spot I will just briefly touch to get to the top, and then finishing up is we're still standing still. We have figured out how to respond to all these kinds of problems in a good way, so either by withstanding him, so giving the Gandalf, you shall not pass, adverse situation, or just being knocked over and standing up very quickly. But, well, it's better if we want to be better off afterwards, we need to learn from the adverse situation. We have to introduce some kind of learning, because, and here, the basic response types of resilience, they help you to understand that. So, there's 4 types of response. The first one is withstanding. So here, you shall not pass. So resisting situation. Recovering, being knocked over and standing up very quickly. So this is basic resilience. But there are 2 more ways to respond. The third one is adapting. Learning, improving is, oh, it's always coming from here. Let's move over to this position. Let's move over to that position. So adapting to this changing threat surface, step by step. And sometimes even to transform, so to reinvent yourself. We saw that a lot with companies in the beginning of the COVID phase. They said, well, if we move on like we always did, we will die. So we have to reinvent ourselves, basically. And that's anti-fragility, basically, including this one. By the way, Taleb crippled definition of resilience to the first two won, and that's why he got away with his reasoning. This moves us up to the peak of resilience, which is again different. So we embrace adversity of an opportunity to improve. We have different kind of questions, which goes in how can we set up as an organization, how can we establish, continue learning, and. Not going deeper into that one. Because it's time now to say, yeah, we're up here. On the peak, we made it, our journey. Nice view out there, but we came up from down there, and we are mere software engineers, so heck with it. And now we're talking about changing organizations, or even changing organizational boundaries and how we respond to the market. Hey, that's not my pay grade. So do I always have to go for the peak? And what I would say is it depends on what you try to achieve, basically. Value feature completeness. Don't do that anymore. If you're there, well, try to change it or leave it. It's not a good idea anymore, because it completely goes beyond this. It doesn't work together with today's systems landscapes. Stability, yeah, if, as I said, not too high availability demands, planned downtimes possible, and so on, systems not distributed internally, and then could be okay. You may get away with that one. It's quite easy to achieve, again. Robustness, if the demands are higher. Still, we're not on safety-critical ground. And especially if your system is distributed internally, so if you're using Microsoft and so on, you have to go for robustness. Basic resilience, this one you need if you go into the area of safety-critical systems, because you don't want people to die. And also it helps you to move under very high uncertainty in very unpredictable environments, because we expect surprises to happen. And this one basically is what I call the successful game, endless game, in an increasingly VUCA world, uncertain world, basically. It's usually, well, it's an important topic, but it's not a technology topic. It's somewhere out there. It will also affect us, but it's different. So depending on what your requirement is, you do not have to do the whole journey. Maybe robustness is okay. Maybe you have to move to the plateau of high resilience, basic resilience. Maybe stability is even sufficient. And yeah, that's not real resilience, but that's okay. You can also call it resilience. I won't sue you for that. That's okay for me. As long as we both agree that it's not actual resilience. Last question then is, and how far will you go up? So wherever you go, whatever your journey will be, I wish you good luck with that. I wish you a great time with that. And I wish you a great conference. Thank you.
Thank you, Uwe. Thank you for that wonderful presentation.
Yeah. Thanks a lot.
We have 5 minutes still. We have some questions. If you put them up on Slido. Do we have any questions on Slido at this moment? There you go. So, catering for resiliency often requires monetary investment. How do we show big business that resiliency is worth it when they really see the negative impact?
Basically, I recommend to you some kind of, it's an inverse business case, because resilience doesn't make any money. If you're not doing it, you're losing money, and you're trying to carve out the risk of these things happening. Best thing is start measuring. How often are your systems down? How much money are you losing in this time? How much of customer churn you have because of unsatisfied customers, because your systems are not running properly, and so on. By the way, it also defines your resilience budget that you have. That's the approach that I usually chose, because if you're not losing money, it's not worth doing anything. It's an economic world. Can't change that one. So we have to come up with some kind of economic figures for that.
Okay. How can an organization skip one or more plateaus, climb faster?
Maybe you can skip the stability plateau and immediately move to robustness. But I think you need some time for the journey because as a human, you can only absorb this much of change at one moment in time. You maybe have noticed with yourself on some journey that you were on. And also organizations, they also need some time. So you do a change, and they need some time to get used to it. And you need another change, you need some time to get used to it, and so on. So probably you maybe cannot really skip the plateaus, but maybe your journey can be a bit different than this prototypical one. So maybe you advance a little bit faster in the one direction and a bit slower in the other one, and so on. But it will take time.
Okay. Resilience have already changed the job requirements. Kuber, cloud configuring are everywhere. What other requirements for devs may we expect in the future?
That depends on where the journey is heading. Because, maybe we have to get used to use a little bit of more AI or something like that. The interesting thing is, if you think about function as a service, for instance, it's a very different paradigm to Lambda and all these things. It's reminding me more again of what I've seen in mainframe times. It's more like a transaction monitor, like it's handling it. So you have these small pieces of code, and today's Copystrecken in German, I don't know how it's called, these areas where you pass parameters, these have become events and all these things. But basically it's a very different paradigm, and you need to know less actually to use this stuff because the environment takes over more. So maybe we can see a split in what we need to know. So like in the past, there were organizational programmers and application programmers and system programmers. And so maybe we see more application programmers. But in the other hand, here with resilience, if we go back to that one, is more understanding maybe, but we already heard that before. Bit curiosity of the business domain because it shapes what we are doing, basically.
Okay.
Maybe that's the nutshell version.
I have
more details.
I have one little quick question, and that is, I was in the military for a long time, and one of the things we were taught is if you make a plan, the minute the shooting starts, the plan goes out the window and expect the unexpected. So I was quite surprised to see that expecting the unexpected was such a high plateau. Why is that?
Because I don't know. There are still, especially in management, a lot of people are still thinking that they can control things, but control is an illusion, actually, from what I've learned. And this having everything under control, so give me the perfect plan, because not having everything under control is weakness, or something like that. Weird psychological things going on. And yeah, it worked halfway more. Not so well, but it worked good enough that they still stick to this illusion. But I think we will all learn from the way how our systems evolve, but also how the business evolves, that it's an illusion.
The last question is probably a one-word answer. Do you have a longer version of this presentation?
Yeah, it's on the speaker deck account. There's a longer version of the slide deck with some more stuff in there. So speakerdeck.com, Ufreed, there you can download it. I will also upload an updated version soon. And as I said, on my ufreed.com account, I will create a written down version of that one. Then you can either listen to the recording of the conference, or you can read the full version on the blog then.
Okay. Thank you very much, Uwe. What a wonderful presentation.